There it goes. Alrighty. How'd Hangman go for you folks? It's really hard if the word is only 3 letters. Like to win that game, it's real difficult here. So, we talked Monday in lab about it here. So I did go add an example. Like this is what it might look like to play the game using the functions. I'm in the right class. I put that in the wrong class. Oh my goodness. Yeah. Okay. Give me half a second here because that is wrong. How did that even happen? I put your project, the other class's project, in your project. Sorry. Give me just 1 second to fix that because they're going to be super confused looking for their project. Yeah. Oh, wow, that's awful. Percentage points. There we go. All right, so this is not your project 3. I'm sorry, that is nuts here. We'll just pretend like that's not there. And then get rid of that rubric too. Okay, I'll come back to that. Sorry. Project 2 is what we're working on here. Obviously, I need more coffee today. This extra large has not been enough. So this was the example gameplay. I said, hey, this is kind of what it would look like to use all of these functions here. It's not a lot of code, actually, to play Hangman because we've done that functional decomposition. We said, let's take a big problem and break it down into smaller problems, right? And I strongly suggested or asked and said you'll be scored on doing these functions as designed, right? That idea here. Because I know there's Hangman solutions out there, but we want to do it in a specific format, and that's more fun that way. This is for project 2. Do I already have something called project 2? What do I already have that's called project 2? I don't think I did that. All project 2. What's in here? I'm sure I'll open with PyCharm. What's in my project 2 right now? Real confused. Yeah, cancel. Oh, okay. I did. I gave you the gallows and the word list, so I can just open that. That's there we go. That's right. I started this for you. I can remember. So here's the like sample word play essentially. Now in here, then we needed to go and figure out what all these functions did. So we can define a get random word here. Would return a value. Let me zoom that in here. Sorry. And then we had a right. So if we have the word list, right, we want to return a word list. Oh no, we want random dot choice of the word list. Right. We looked at random choice, I think, briefly. But the other way to go about it is you generate a random index between 0 and the length, but not including the length. Right, to pick a random index out, but random choice is just as fast here. And we'll just pick one of them for us. Either way is perfectly fine. Those are some free points, I think. And then we'll define as the word been guessed, given the hidden word and the letters guessed. And eventually this should return some sort of true or false value here, right? So how do I know if I've guessed the hidden word? If I know what the word is, I know what the letters guessed are. Well, I'm going to go through the hidden word letter by letter by letter, and if you haven't guessed a letter, you haven't guessed the whole word, right? So I can say for letter in my hidden word, if my letter is not in the letters guessed, I'm going to return false, right? If I find a letter that's not been guessed, return false. You haven't guessed the word. If I go through every single letter in the hidden word and it is in here, if I haven't returned a false, that means every letter must be in the letters guessed here. I can return true, right? going through every letter. Is it in something you've guessed? Yes or no? If it's not, I don't need to check anything else, right? But if I checked every letter and I haven't told you no, then it must be true. Okay, has the person been hanged? This one's super easy here. This was like basically 3 points, right? We're going to return my number of incorrect guesses equals 6. If you have 6 wrong guesses, you get hanged. I guess or greater than or equal to is probably fine too, right? Because you get the head, you get the body, you get the left arm, you get the right arm, you get the left foot, you get the right foot, and then you're dead. Because somehow being on the gallows without a foot means you're not dead. This is a really weird game for children, I tell you. But sure, this is what it is. That's all this one tells me, whether or not I have this many incorrect guesses. Okay, to display the hidden word, given the hidden word and the letters guessed, right? Same idea as this, but it's a little different, right? I'm going to go for every letter in the hidden word, and then if the letter is in the letters guessed, I'm going to print out the letter. And then I don't want to go down a line every time. I want to space separate these things. Remember, you can change that ending bit of print so that you're not getting a separate line every time. I'll just print the letter. If you didn't guess the letter, I'm just going to print a blank space, right? And again, I'll change the ending character via space here. After I've checked every letter, I can print a new line just to go down to the next line, right? So every letter in the hidden word, if I've guessed it, print the letter. If I haven't guessed it, print a blank. This will display the hidden word based on what I've guessed. Right? I think a lot of people were overthinking this one. I saw a lot of really cool, interesting code where like you were doing slices and putting things together and having a bunch of blanks and replacing blanks, and that's fantastic, but you did more work than you needed to, right? And that's okay, right? You know, if you got a solution, that's fantastic. I'm proud of you. That's awesome. That was the goal, is to get a solution, right? I'm going to show you all the shortcuts because I'm lazy, right? And that's okay, right? Okay, that'll display the hidden word. And then to get a letter guessed here, given the letters already guessed. Now, this one I had a small trick here that you might not have seen. And you actually asked me about it, so I assume you probably all figured it out. But that's okay. So we assign guess. So we're going to return the guess here to check whether or not it was in the hidden word or not. Hector, my friend, thank you so much for donating those bits to the scholarship fund here at the University of Michigan Dearborn College of Engineering and Computer Science. I need more coffee. I made espresso yesterday in the little mocha pot thing, and it was amazing. It's really good. Really excited. Right, so to get the letter guessed, given the letters we've guessed, if you never change letters guessed, so you don't see me taking the guess and putting it in the letters guessed list. Right, I make a list here, but you never see me change it. So hopefully that was the clue to you, like, oh, hey, maybe that happens in the function. If you did it separately, you just added another line, like, you know, get my letters guessed, dot append the guessed, append the guess, perfectly fine. Nothing wrong with that at all. But like, if you didn't do this and you just use my sample code here, you never would be adding to your guesses here unless you did it in your function. It's just an option, just a way of going about it here. It's perfectly fine. So this is the only function that deals with input. Right? We're going to ask the user to do something here. So we'll get a guess is an input of enter a letter to guess. Right? That's it. And this one is supposed to make sure that we only have one letter and make sure that it hasn't been guessed before. So this is probably in a loop here, right, to make sure something happens. Now, we've got some options. The lazy option here that I'm fond of here, I'm going to say while true, which is a really weird way to have a loop because it's just going to run forever. But what's going to happen is if I gave you something that you haven't guessed before and that it is a length of 1, I can return that value, and return stops the function. The loop will end as soon as I hit the return word. Again, if you didn't do that, that's okay. You just had more work than you needed to. Not a problem. And don't feel bad if you didn't think of these shortcuts. It's okay. Again, I've been doing this for a lot of years now. So a lot of these things, like, I'm familiar with. And you're still learning, and that's okay. So you're learning the tips, you're learning the tricks, you're learning the ways to get it done. As long as you have a solution, you're perfectly fine. I don't want you to feel bad about if your solution looks different. Right? There's lots of different ways to solve our problems. We're going to say, hey, if the guess is not, oh, sorry, we don't need these parentheses. If guess is not in my letters guessed, right, and the length of guess is 1, I'm going to return the guess. Right? If you haven't guessed it yet, and the length is 1, let's give you back the guess. Now, it might also be nice to uppercase all these things or lowercase all these things. So all of the words here were in lowercase. So you probably want to lowercase their guess here. Probably. Because if they type an uppercase letter, remember Python's case sensitive, I will never find an uppercase A in any of these words. So at some point, you probably wanted to lowercase it or take your word to uppercase. I mean, just go one direction or the other. Doesn't really matter. Uppercase might actually be prettier, but that's okay when we play Hangman. I think we can figure it out. So if I didn't return, the loop will keep running. It will keep asking you for a letter to guess. Now, it would be nice. So there's no points for doing it. I didn't tell you specifically that you're supposed to do any of this. But we could say, hey, if the length of guess is greater than 1, we could print out, please only guess 1 letter at a time, or something like that. Or we could say, if my guess is in my letters guessed, we could print, you already guessed that. Right? Just some helpful things here, not necessarily required. So I think we just said, ensure it's a single letter, and don't allow them to guess. So I didn't say, tell them they've already done that. So if you just prompt them again, that's perfectly valid. You're probably going to confuse your user though, because like it'll say enter a letter, it'll say enter a letter, it'll say enter a letter, and they keep entering A, and they don't realize they've already guessed A. You know, let's help people out. Let's assume they don't have a good memory, which is probably fair, right? The mental load that we all have nowadays, with like how much stuff is in our head. I can't remember what letters I've guessed in Hangman, especially if you're not printing them somewhere. Like it'd be nice if you like printed out, hey, you've already guessed all these letters, for me to pick the next one. So some sort of option here would be nice. So I'm just going to tell you, hey, you already guessed that. And this loop will just keep on running until it hits the return. Right? Once it hits a return, loop will stop, the function will stop. Loop is done. I'll get my letter back out. And the last one here was printing the gallows. We had a gallows here, so we could have a print gallows function, print gallows, that takes a number of incorrect guesses. Right? Takes the number of incorrect guesses. Now, this one is kind of silly here. I'm not particularly proud of any of this here. I'm just going to make 6 different gallows here, or 7 actually, right? For 0, for 1, for 2, for 3, for 4, for 5, for 6. And that's what I'll get you. Right? It's a lot of duplicate code essentially, but they're like duplicate strings. I don't know. It's probably not the worst thing. And we should actually tab that in one because we have this raw string here. So we can say, hey, if my number of incorrect guesses is 0, let's print this thing essentially, right? Or we could like assign gallows and just print it at the end. That's probably easier because I only want one print statement here. So we'll say print the gallows at the end. So if the number of incorrect guesses is 0, here's the gallows to print. Right? Elif, my number of incorrect guesses is 1. Oh, sorry, if this is 0, I should get rid of all those body parts. I'll do that in just a second. If it's 1, here's my gallows. Again, this is tabbed in real bad there. I think that's how we want it. All right, so with 1 body part, that's just the head, right? With no body parts, oh, I still want that copied though. With no body parts, it's just an empty gallows, right? Else if it's 2, if it's 3, if it's 4, on and on and on. This is my least favorite part of this here because it feels really bad, but I don't have a great way of doing this in code otherwise. Copy that. So that's 2, 3, 4, 5, and 6. So 2 then is the head and the body, right? Elif if it's 3, then we get head, body, and 1 arm. Right? Elif if it's 4, oops, 3, 4, then we get both arms, but no legs. Elif it's 5, you get everything but 1 leg. And if it's 6 here, and really I could say like greater than or equal to 6 might be, just in case something screws up somewhere, right? I'll at least get some value. This is like my default here, or really that could just be an else at that point, right? If that's all I care about, Just if it's not 0, 1, 2, 3, 4, or 5, you must be dead. You got hanged. And we'll print the gallows out. So again, that's my least favorite here because it doesn't feel clever, and I really want to be clever because it makes me feel good to be clever, but it gets the job done. So you could kind of do this and say like, hey, if the body part is more than 0, print a head here, and then if it's more than 1, print a body. If it's more than 2, print an arm. But that I think is probably even more clunky than just doing it this way. But that might be a fun way to go about it here. So is that okay? Now all of this should happen as long as we want to keep playing again. Right? So we can say, how about play again equals a y, and while play again does not equal a no. How about I kind of like that. So like anything other than an n, and I'm going to keep playing. It's probably fine here. And then when this loop is done, right, we either lost or we won. Right? We should probably tell them what the word was. Right? We could print the hidden word, something like that, just to tell them the word was. Here, let's do the formatted string, right? Right? The word was the hidden word, and then do you want to play again? Equals an input. You want to play again, and then again suggest a y or an n here, and maybe lowercase their input because we're specifically looking at lowercase n here. Right? And then the loop will come back and play again. I think that's it for Hangman. Should we see if it works though? We should try it. Oh man, we got a long word here. Okay, what letter should we guess? E. Okay. Well, still printed blank. That's interesting. Do we not increase our number of guesses? If it's not in the hidden word, it didn't go up by 1. Do we do the wrong thing with our print gallows? If it's 1, no, we should have printed ahead. All right, something's not working right. That's interesting. Play the hidden word, get the guess, print the gallows, enter a letter to guess. Well, it wasn't an E. Oh, no, I never did the thing. Sorry. That's what's wrong here. Remember I mentioned if you never add the letter? I said it and I forgot to do it. So if it's correct, I can go and append it in here. Right? Because when you pass a list, remember you're giving them access to that mutable list. I can go change it inside the function. I can't go assign it to a brand new list, but I can modify the list. I can add things, I can remove things, I can change things inside of the existing list, right? Because we're passing them the list. If you don't want them to do that, give them a copy of it, right? With slicing, that's the easy way to go about it. But it's actually handy here to let our function do that adding, if you remember to do it. Because, oh, now we don't get to see the word. Now I feel bad. All right, this was not as long. Yeah.
When you do that, is it okay to name it the same thing that you did in document? Is it still good practice?
So the name only matters inside the function. So we can call it anything we want inside the function. It doesn't have to be the same name as something else. I like using the same names because I get confused easily. But it could be like A here, and then I could say A.append. You know, and if it's for if it's mutable or not, you mean?
If it's not.
So if I pass something that wasn't mutable, I'd have to return the value then if I wanted to like save the results of what I changed. So it just depends on how we're handling this. So I know it's mutable. I know it's a list. I know I can change it here. Does that make sense?
Yeah, I just didn't know if by convention probably the way naming things the same.
No, I like naming things the same. Some people think it's terrible, and I don't understand why they go through all the hassle of trying to remember 2 different names for the same thing. It's just a style preference, really. And it warns you, hey, you've shadowed letters guessed from an outer scope. So some people have gotten into the habit. I'd like you to try and not of putting all your variables at the top, and then all your functions can access them. When we talked about classes, we haven't got quite to that idea yet. These are now like global variables that you have access to everywhere. Generally, we want to avoid global variables. They tend to be a little messy. So we want to try and keep variables smaller in scope. So keep them inside of functions, keep them inside of classes, that sort of thing. People will still use global variables, and there's good reasons to use them, but as a habit, we want to try and not. So like you don't really need any arguments if you just define all of your variables at the top here. It would work, but it's considered bad form, and then we're not really getting in the habit of passing things that we need to functions. Right? That's a better way to think about things, and will probably work a little better. All right, so let's try a letter to guess. E again? All right, there's an E. What letter should we guess? R. Uh-oh. No R. T. No T. You're leading me bad here. S. No! Oh my god, what word is this? L. A? No A? A U?
No.
The word was chicken. Okay. So, we got hanged. Should we try again? Yeah, we gotta try again, right? So let's give it something longer, right? One letter at a time. Right, E, 2 E's. Okay, if we guess E again, you already guessed that. We want to make sure the code does what it's supposed to do, right? Try these things we wrote in here. Make sure it happens. All right, what else should we guess? N? No N. S. No S. T. No T. I'm sorry? D? M? Nope. F? Oh, there was an F. All right, we're not dead yet. There's a blank here, so I don't think it's elephant. R? Peaceful. All right, we got to win once. I really want to win once. Make sure like that will stop the game when we've guessed the word. All right, here's a nice 5-letter word. We try E again. 2 E's. Oh, yeah, this will be easy, right? H, T. There's a T. It's not yeet, right? Yeet's too short. S. H. Oh, we already guessed an H. L. Not an L. W. Sweet. Hey, we won. Yay. Good job. That was exciting. All right, have we tried all of our code? I think we've gotten every gallows. We tried our different ifs here. We got the letters printed. We figured out the word. We guessed it true, and it stopped our loop correctly. Right? Feeling okay? All right, awesome. So let's say no, we don't want to play again, and it stops. Feel pretty good about it. Okay, this is using functions, taking a big problem, breaking it down into smaller problems. Now, not everyone thinks the same way I do. Go figure. I'm a little weird, and that's okay. So this specific exercise gave you specific functions. That's not how things will always work in the real world, right? Usually you have the freedom to solve things however you want. I sort of like this as an example here because like these are, I feel like nice and small chunks. I don't really know how to make them smaller. But that's sort of an exercise you can do as you're solving a problem is, well, this function's doing a lot. Could I have it do less? And people have all sorts of different styles or rules of thumb and how they go about designing these. And a lot of people like to say if a function doesn't fit on the screen, it might be doing too much. That's just a way to think about it. Like if you have to scroll down to see what your function is doing, it's probably doing a lot. Now our print gallows is a bad example of that because it's really basic. It's a lot of text. So this one I'm going to give a pass. But my other functions, right, if we look at them, they're just a couple lines of code. Couple lines of code, couple lines of code, couple lines of code. They feel relatively concise, and they should do what the function says it does. So it will behave as advertised. Right? This will get the letter you guessed. That's it. That's its only job. So I think when I talked with a lot of you folks here, you were biting off more than you could chew, and like I want to do 3 different things in one function, which is, I mean, it's all necessary things, all things we had to do here. But the idea was to break it down into smaller and smaller and smaller and small pieces here because generally it's easier to solve a small thing than it is the big thing, right? And just as a thought exercise, if I said go build a hangman game, And by the way, don't go Google it, please. Do you think any of you would have come up with functions like this? What functions would you have had? Like, how would you have broken the problem down? This might be a useful discussion here, just to think about how would you go about breaking the problem down? What steps would you have taken? If I said you have to have functions, but didn't tell you which ones.
Probably.
Similar ones?
It's easier to debug.
Yeah, debugging. So like, I have a problem specifically with getting this letter guessed. That's nice to separate that out from the big piece of things, for sure. Right? So with any problem we run into, we can break it down into smaller steps. So I used to spend a lot of time trying to explain the thought process behind it and get people to get words down in English. And recently that hasn't gone as well. So I kind of got away from that. But essentially what we did with something like this is you have code, but it's not really working code yet, right? And this is probably more code looking than an English version would be, but there's this idea of pseudocode, something that is like code. If you can take a problem and decompose it into those small steps and build out some pseudocode and say, okay, here's step one. This is what I'm going to do just in English. Here's step two. This is what I'm going to do in English. Here's step three. This is what I'm going to do in English. You can solve a problem mentally. Right? You make this model of it. This is my idea for how I'm going to solve it. And you can even test your model. You can say, okay, before you even have any code here, so let's say the hidden word is pizza, and I guess an E. What's going to happen? All right, well, I haven't guessed E before. Okay, sure. All right, now I need to go print the hidden word. Right, okay, so P. Have I guessed a P? No, I'm going to print out a blank. Have I guessed an I? No, I'm going to print out an I, or a blank. Have I guessed a Z? No, print out a blank. Right, kind of taking it through step by step by step, just mentally in your head, getting a solution, making sure it works, and then writing the code. So that again, why I'm really into software engineering, and I think it's fascinating because it is an art of problem solving. The science behind how do I take a problem I solved and turn it into code and turn it into efficient code and that sort of thing, that's fun too. And there's definitely right ways to go about that. But mostly what we're learning is the art of problem solving. And how do I take a tool and a technique and a trick and how do I make the computer do this thing that I want it to do? Because to solve that problem is difficult. 5-year-olds can play hangman on a chalkboard. But if you try and get them to like write down every single step in simple enough terms that we can turn it into Python code, they might have a hard time with it. They get the concept, but communicating that concept at a step by step by step by step by step level can be difficult. So interesting. I'm a big fan of board games, and I play a lot of board games. And more often than not, now I see the instruction manuals come with a link and say, "Hey, watch this video." Because giving instructions for a board game, especially the board games I like that are long and complex and have a lot of rules and these sorts of things, like it takes half an hour to read the rule book. And then by then, most of my family doesn't want to play with me anymore. My son does. He likes games, long games too, but my girls are like, they've lost interest. Like, no, this is boring already. Like we haven't even got to the game yet. So it's a running joke when we have family game nights and my wife's sibling comes over and in-laws come over. Like, if it's a game we haven't played before and I'm going to read the rule book, they just like start making fun of me already because it's going to take forever, and that's okay. It's fine. Breaking things down into step by step by step by step is difficult, even for a board game. That's why instruction manuals are so long, because you have to break down every single step. And this is what happens, and this is what happens, and this is what happens, and this is what happens. This is what you do next, and then if someone does this, you have to do this. And they're essentially writing code almost with an instruction manual. It doesn't look like Python. It's English. That's kind of how we go about solving problems. Is if we can essentially write an instruction manual for it, we can do it. And you have to be really detailed. There's a funny video. I don't think I talked about it before, where people ask their kid how to make a sandwich and have them write down the steps to make a peanut butter and jelly sandwich, and then they literally follow the directions. So if the direction says put peanut butter on bread, they take the jar of peanut butter and put it on top of the bread, because the directions didn't say spread the peanut butter, or like take a knife and spread it. And if the directions said spread peanut butter, they take their hand and scoop it out because they didn't say use a knife. And it's like a funny video, and the kids laugh and get a big kick out of it. But like that's the idea. We need to get this down to simple, very detailed steps here. And that's what we're going to be focusing on with the next project as we use classes to solve our problems, because classes allow us to interact with things in a little bit more of a natural manner for us. Now it's going to feel weird because it's brand new, but when we think about, hey, I've got this tree, and trees will grow, right? I don't need to figure out all the different steps of, okay, I need to have this tree variable, and I need to have this tree variable, and I need to have this tree variable. When I'm doing that pseudocode idea, like, hey, I want to, let's do a 3D design for someone's landscaping. And you're like, I'll put a tree over here, I'll put a tree over here, I'll put a tree over here. It's this one's an oak tree, this one's a this tree, this one's a that tree. Here's their colors. And then let's see, what will it look like in 5 years? Have I put the trees too close to each other? Let's call grow. Let's call grow. Then see what the size of the trees are. Again, we don't have all like the 3D modeling, all that cool stuff, but like that's the idea. I can interact with a noun of tree to solve my problem, rather than I need to be tracking different a tree height here and a tree height here and a tree height here, and then I need to track different attributes. It gets messy easily. So in terms of visualizing and modeling and thinking through how we solve a problem, using classes can help with that. Because we encapsulate all of our details, right? We know all the attributes about our class in one nice little package, and I can interact with it abstractly with its public functions. You define the function as public, someone can use it. You define an attribute as private, they shouldn't go use it, right? They should use that public function, that idea. So we can give people a way to use our code and model the real world in different manners. So if we wanted to go, let me pull up our previous project here. Those classes. All right, so this was our vehicle, right? We could go drive our vehicle. We could see whether or not we had enough battery charge to get that distance, right? So if I was doing a trip planning, I'd say, hey, you want to go from A to B? You don't have enough charge. Tell them no. They need to go plan, hey, go to A to C where there's a charger, go charge, and then go from C to B, or whatever. Like we can use that in our code here. Another idea, we might have a class like bank account. Right, so we're going to have our init method here. We're going to define the init method. Now, bank account, if we have attributes that we want to know, right, we put them in init method. So when you start a bank account, you probably tell them who the owner is, right? If you don't tell the bank who owns the bank account, it might be hard to get your money back out later. And like once you own a bank account, you don't want the bank to change that, right? So we don't want to give a public function to change the owner. So this idea that if it makes sense for your class to have an attribute be essentially read-only, you set it once and then it never changes, that's perfectly fine. Don't give them a set method. Like just because there's an attribute doesn't mean you need to give someone a set method. You write set methods for the things that should change here. So you tell them an owner, and that's fine. So then we'll have our self.owner is the owner, right? These self.attributes are this instance of bank account has its own set of these attributes here, which is good. So I can have a bank account, you can have a bank account, someone else can have a bank account. They're all separate bank accounts in memory, each with their own separate owner, which is good. Okay, and then I'll have a self.balance. Oh, we'll start off at 0, right? So when you start an account, it has $0 in it. Now, we want a way to get the balance back out, right? You should be able to go and ask your bank, hey, how much money do I have in my account? So we'll have a get balance function that returns the self balance. Sure. But now, do you ever go to the bank and be like, hey, my balance is now $10,000? The bank will be like, that's fun. Where's your $10,000? You don't tell them what the balance is, right? So we don't interact with balance in a set balance kind of manner, right? The way that you interact with your balance is you can deposit money and you can withdraw money, right? So when we think about this as a noun and it's the way that people interact with it, right? Its attributes are the values that each instance will have, like who owns it and what the balance is. And then the verbs, the things we do with that noun can become our functions, like a deposit. And then there's an amount here. So you tell me what the amount is, I'll go deposit for you. And again, we can add some sanity checking. We can add some bounds here. Like what is a valid value for an amount to deposit? Well, for our purposes, it's not negative, right? So if the amount is greater than 0, sure, we'll go do your deposit. If you give me a negative number and say, hey, I want to deposit minus $100, the bank's going to look at you funny, right? Like the poor teller is going to be really confused, and they're already having a bad day because people just don't know how to be polite anymore, which is crazy. My wife went out to lunch with her friend yesterday and said the waitress was almost in tears because of another table. Like, why are you yelling at the poor waitress? Like, if your food came out slow, it's the kitchen's fault. But don't even go yell at the people in the kitchen. Just don't yell at people. Just like wait patiently. I don't know. A little patience goes a long way for sure. So if the amount is deposit is greater than 0, we're going to take my self balance and we'll add the amount. Right? You want to deposit $100? Sure. Let's take my balance and add 100 to it. Whatever the balance used to be, we've now increased it. Awesome. How about a withdraw? Define withdraw. Now, is it withdraw or withdrawal? I can never tell the difference. So you do a withdraw, but the withdrawal is what you got out? Okay. Oh, man, this stuff is hard. So I want to withdraw a certain amount. Now, again, it's got to be a positive amount here. I want to withdraw $100. If you wanted to withdraw a negative amount, my arithmetic here is going to get funny, right? Because like we're going to subtract the amount you're withdrawing from your balance. But if you give me negative, subtracting a negative actually adds money. And then like you go up to the ATM machine and you like, how much do you want to withdraw? And you put in a negative number and it takes it. You now have unlimited money. So I'm pretty sure the ATM machines do some sort of sanity checking here too, right? Same idea. So if my amount is greater than 0, we'll take, but in addition to this though, there's more bounds checking we need. Now, we're not debating banks and overdraft fees and all the nonsense and how they actually make their money, but our bank here will not let you spend money you don't have, and we just won't charge you fees because that just makes sense, right? I don't know why we can charge someone $35 and let them spend money they don't have, and now they have, in addition to the negative money, they have additional negative 35 on top of that we charge them, and then every day charge them even more. Like, how do people get out of the hole? They don't. It's awful. It's terrible. And I hate. So go to a credit union instead of a bank, and they will actually be reasonable. Just so much nicer. Anyway, so if the amount is greater than 0, and my amount is less than or equal to my self balance, right? If both of these are true, then we're good. Now it's telling me, hey, I could change this, right? With Python, we can put like a number in between here. We could say the amount is greater than 0 and less than or equal to the balance, right? You can sandwich it here. Other languages don't let you do this, but Python's nice and friendly. They're like, hey, this makes sense. 0 is less than the amount, which is less than the self balance, right? Or the amount is greater than 0, but less than or equal to the balance. However you want to read these, that's just English here, right? If it is, great, we'll take our self balance minus the amount here. Right, so now I can interact with my balance by withdrawing money, depositing money, see what the current balance is, and that's it. So now I have a noun I can use, I have my bank account I can use in code to do these sorts of things. Now again, this is not the most interesting yet because it only exists while the program's running. We haven't gotten to working with files yet, so like I can actually save the data when my program's not running. We'll get there, I promise. Files are really fun. But for now, like this kind of represents a bank account here. It's a noun, and I can use it when I solve all these problems, right? It's protecting the integrity. So I should make the balance private here. If you just rename something like that, self balance, all these other ones are going to get confused here. So I could go rename all of them, or I could let the tool do it for me. So if I right click on balance, I have an option here for refactor rename. I wish it would be in the main menu because like usually you right click rename things and it's hidden. You go to refactor rename and say, hey, I really want this to be called underscore balance here, and you hit refactor, it changes it everywhere for you. Right? Renaming things is a common practice. So the tool will do it for you and do it everywhere it finds that same name. It saves you a lot of time, energy, and effort. Right? We're lazy. Okay. For owner, again, probably should make this private as well. And then if I have an attribute, I need a way to get that attribute back out here. So I need a get owner method. So we can define a get owner return self owner. Right? We'll give you back that string value over here. Here's the owner. Or it's probably a string. Right? But notice there's no set owner. There's no set balance. We don't interact with our class in that sort of manner. You can't change the owner. If you want to change the owner, like close the account and open a new one. Right? I think that's what banks do. They don't just say, oh, hey, we're going to change the owner here. It doesn't work like that. Right? Take all the money out, close it, open a new account. They probably have account numbers and all sorts of other interesting stuff. We don't really care too much about the account numbers and routing numbers, but we could add those in if we wanted, right? If you wanted to have a self account number. Sure, we could do that as the account number. So tell me the owner and an account number. That's fine, right? Then we could add a get account number. Fine, get account number function to return the self account number. Sure. So now you can make a bank account. You tell me who owns it and what the number is. Okay, this is account number 29541327862, whatever shows up on your check, right, for a checking account. Why not? Again, it probably makes sense that this is read only. The bank probably won't change your account number, especially if it's a checking account, because then when you write a check and it has a different account number, people are going to get confused and your checks will probably bounce. And then lots of people get mad, right? Which still, it's 2022 and it takes a day for them to figure out whether or not you have enough money in your account. It's a bunch of nonsense. Like that should just happen instantly. So anyway, the financial system's a whole other interesting story. We talked a lot about the real world being messy, right? And we write code to try and model that messy. It gets really complex. Just kind of fun, right? And that's literally what you have to do if you want to write code to represent these things in the real world. We have to think about all the messiness, and that's why code gets complex, and that's why software developers make a lot of money, right? It's a relatively special skill that you have to learn, right? Not everyone can do it, right? So we do pretty well in the industry. So I remember as a kid, right when I went to college, everyone was like, "Oh, they're going to outsource all the programming jobs, and there won't be any programming jobs in America. Why are you going to go learn how to code?" I was like, "Oh, I like computers." It's worked out well so far. So I can't guarantee anything, of course, but even now with we have global distributed teams across the world, and we still have a very strong presence of developers in America, right? And the jobs haven't gone away; they've increased since I went to school, which was years ago. Um, it's cool. Literally every industry in the world now uses code, software for something. I don't think there's any industry that doesn't. Right? Everyone's doing it. Even farming, which I posted an article. So if you're in the Discord, I post interesting articles in the interesting stuff channel because I find it interesting. Now that tractors are getting smart, like they can drive themselves, they have like self-driving tractors now. Like it takes a little map and like here's my field and we'll go and do all the things it needs to do. You still probably want an operator there in case it gets confused, but like that's a pretty easy thing to automate because it's probably not going to run into another tractor. Right, where like self-driving cars are difficult because there's lots of other cars on the road and humans drive those cars and they do unpredictable things, right? But tractors are nice. But now it turns out now that tractors are getting smarter and smarter and smarter, someone found a way to hack a tractor and make it go do crop circles, which is probably pretty sad. I don't think he actually did crops. I think it was more of a demonstration. But like anytime you have a new tool that's really cool, you're going to have those people who are like, I can use this and do bad things with it, which is really unfortunate. But every industry has technology and has software that does stuff for them. So it's definitely not going away. Okay, how do you feel about classes? I know it's a new topic here. Let's take a look at the Zy book. I haven't actually opened it yet for this chapter, which is fun. I think usually I have to open it more often. And I think, did I turn on all the labs? Or did I stop at a certain chapter? I know I did a bunch. I don't remember if I got bored and stopped. Yeah, I turned on those. Okay, I stopped it after classes. I got to classes at least and turned on all the labs for you. So ways to group data, methods, objects, examples, constructors. That's the init method. The interface, this is interesting. We'll get more into this topic if we continue on into the 2001 course. It's more of another fundamental of object-oriented programming. This interface idea is like that abstract class that we interact with. Here's the public functions. A lot of people, you might hear people say an API or an application programming interface. That's all the public functions you get. That's your API. That's your interface here. You can do other interesting stuff with them. Just like we can have variables, attributes be private, you can have private functions as well. Right? So if you want a function that you just use because it's useful to you and you're using a function to name something or using a function to reduce repeated code or using a function, there's a third thing and I'm not thinking of it right now. Right? You can have private functions in your class that just you have access to, which is cool. This abstract idea. Okay. Other cool things. So this double underscore is really fun, but like, so let's go make a bank account here. Let's do this maybe up top here. Over here. So if I want a bank account, right, I'll say here's my checking account equals a bank account. Given this is Eric's account and it's, you know, number 1234. If I just print my checking account here, what do you think I'm going to get? Is he going to say Eric's account balance is 0, you know, account number 123? No, you get garbage. You get bank account object at essentially the memory address. So if you just print something that's a class, you get weird stuff. But it's telling you, hey, this is a type of bank account. It's an object, right? It's an instance of this class. Objects are instances of classes. Just another word for it here. And by the way, this is where it is in memory. We could care less. This is not helpful. So if you want your class to be able to be represented as a string, there's a special method for you. The method, just like init is special, it has these 2 underscores. You can add a special method under, and then if you look at all of these, there's all sorts of cool things you can do with these underscore methods. The absolute value, how you delete something, the hexadecimal version, the integer version, the length of something, this thing as a string, how you add something to it as a Boolean. You can look at division, at modulus. Does it equal another thing? Is it greater than or equal to? Is it greater than? Is it, I don't know what some of these ones are. Wow. Not equal to, is it negative? To a power of? All sorts of cool functions, right? Most of these are crazy. But if I want to represent myself as a string, I can define an under str for string. Like when we wanted to turn something into a string, we said string of something, right? String of a number would be the string value of that number. That's what this function does. It lets you take a bank account and hand it to string to turn into a string. It says, I don't want this garbage here. I want something useful. So we might say we're going to return a string value. So we're going to return a formatted string and say, I don't know, bank account owner is the self.owner, and then balance, or maybe the number is the self.number, and let me break that down a line here. And formatted string, how about the balance? Is self.balance. Right, so we would kind of return that as a formatted string. I didn't line up quite nice, but that's okay. So now when I go print myself, print, when it encounters something, automatically tries to turn it into a string. We don't see that happen, but when you call print, it tries to convert it to a string, to print it as a string here to the screen for us. So it's implicitly turning into string here. So it's really doing print string of checking here. So now when I run, if I have that string method defined, we get that string back out. Here, bank account owner is Eric, numbers 123, balance is 0. Because I've said, hey, this is my definition of how I want to treat myself as a string. You can add a string method to any class that you want if you want it to be handled as a string. It's just a nice, friendly way of letting someone get all the details of bank account. Now, again, being a string is not always the most useful thing, right? We definitely want these get attributes, because if I were to take this bank account and say, hey, it's a wonderful class here, I want to reuse it in a web application, I'm not going to be using a string and showing a string in my website somewhere. I'm probably going to take these different values and do something with them, right? So we still need to get individual values, but it gives me the flexibility to just turn it into a string really nicely. So string's fine. You can customize it. You can do less than, right, to compare myself to another instance of the class. So how do I want to compare bank account to another bank account? Define less than. So there's less than and equal to, there's greater than and equal to, there's equal to, and there's not equal to, right? All those different relational operators we can do here. So I'm going to say I'm less than if my balance is less than, right? So we'll return my self.balance is less than other.balance. Now, it's warning me here. It's saying, hey, you're accessing a protected member of the class. Right? We said this underscore means it's private. We shouldn't be getting it. We shouldn't be touching it. Now, we're still in the bank account class, so it's probably okay. But it's concerned that other might not actually be a bank account and all sorts of other fun stuff there. We can get more into that checking later. But so if we wanted to, maybe get balance is more proper, and then it won't yell at us because we're not accessing it directly. We're calling it a public function. It does the exact same thing. We don't care too much, but this is probably fine here. So now I can make two bank accounts here. So we'll take Eric's bank account, and then we want to put some money in it, right? So it's called deposit, add like $10. We'll print it out, and then we'll make a savings account. Here's a bank account. Given Eric, this is account number, how about 234? And then let's print, I'm going to say checking less than savings, right? Do the formatted string and see what we get here. Checking less than savings, right? Is checking going to be less than savings? No, because I deposited 10 in checking. So the balance of checking should be more than the balance of savings. So it should be false. Right? Checking is less than savings, false. Awesome. Now, it'd be nice if I could just flip that around here, right? And say, hey, is it greater than savings? Look at that. True. Nice. How about greater than or equal to savings? Uh-oh. Greater than or equal not supported between instances of bank account and bank account. I don't have a greater than or equal to. It's not defined. Right? So if we want to define all of these things here, there's like one little shortcut we can do. Right? We can do less than, we can define a greater than here. Now this is just the other way around. Greater than, a greater than or equal to is GE, greater than or greater or equal, essentially. So same idea here, but we add in the equal sign here, and then a less than and equal to, less than and equal to is less than or equal to, right? Now I can check if it's greater than or equal to, because we've added it. Now what if how do I check equals? Right? What if I want to say, do these accounts equal each other? Right, with my double equals operator. Oh my goodness, let's do the right keys here. Can I say, does this class equal another? It says no. I didn't define one. So what it's going to do is it's going to go check that identity of the object, right? Which is basically, where is this in memory? Like, this is unique here, this is unique there or not. So if you don't add in your own, it's really hard to make two equal to each other without saying like checking equal savings and assign one to the other. But if I want to say, hey, they should be equal if the owner is the same, the account number is the same, and the balance is the same, we should call them equal. We could do that, right? We could add our own equals check if we wanted. So we could define an equals. We're going to return self.balance is equal to other.getBalance, right? And self.owner is equal to other.getOwner. And sorry, I need my slashes here. Self.account number is equal to other.getAccount number. Do we not add a get account number? No, we did. Oh, we did. It just doesn't recognize it. Get account number. Okay. So now I can compare equals. What about not equals? Not equals, self and other. Do I want to do all of this and say, okay, if it doesn't match and it doesn't match and or this doesn't match or this doesn't match? Not really. I want to return not self equals other. Right? Be lazy. I know how to see if they are equal. If they are equal, not that. We're not equal. Right? So not equal would be true if they are not equal to each other. If they are equal to each other, this will be true. I'm going to say not true is false. False, they are not equal if they do equal. So sorry, it's a little weird to like all the different positives and negatives here. But I don't need to repeat myself and say, hey, they don't match or they don't match or they don't match. Because if they do match, they are equal. That's it, right? So like if I've defined one, I don't need to define the other. And usually equals is much better because just because it doesn't equal, I don't know. Sometimes you can flip that around and say it does equal, but you know, a not equal, you know, if the balances don't match but the owners and account numbers do, does that mean they are equal? Well, not really. So generally you define equals first, and then not equals is not equals. That make sense? So we can start comparing our class to another class. So less than or equal to, greater than, not equal, yep, so on and so on. All right. Other operator overloading, you could define subtraction here. So I can take one minus another. How do you take a class subtracted by another instance of that class? Now for bank accounts, I don't think that makes sense. I'm not going to say, hey, take checking minus savings. I don't even know what you do with that. But like maybe I could say checking plus savings and just add the balances together. Maybe it might make sense to have an addition but not a subtraction. Like that all depends on what the class is. Right? If it makes sense for your class to add to another one, go for it. If it doesn't make sense, don't do it. Right? It's up to you to define what makes sense for your class here and how we want those to be used. One thing to note when you like subtract here, if you think back to math class and you say, hey, 5 minus 2, does 5 change or is 5 constant? Like 5 is always 5, right? And 2 is always 2. You get a new result of 3, right? You didn't change the value of 5. You didn't change the value of 2. So when you take one class minus another class here, they're not changing the value of self, right? None of these self attributes are changing, right? They're making another time here. So if we were to like take bank account plus bank account, I'm not going to add the balances together in one of the bank accounts. I'm going to make a new bank account with the new balance, combined balance. Generally, that's how things work when you add, right? You don't change one. That one stays constant, the other one stays constant. It's a weird concept to think of. Just keep that in your back pocket. We'll come back to it more next semester. But just because we add two things together, those two things don't change. We get a new result over here. There's a way to think of that. Minus, cool. All the other ones here. Yep. Subtract, multiply, divide, floor division, modulus, exponential, the and logical operator. What does this class and this class represent? I don't even like, these get crazy here. And they've got some special cases here for them. What else do we have in here? Okay, that's about it. So memory allocation. Right? When we create an instance of a class, Python goes out to your operating system and says, hey, I need a place to store this in memory. Right? All of these self attributes need a place to be stored. Right? So it will go and allocate that memory. When that variable is no longer used, when that variable is gone, Python will free that memory up. It's called garbage collection. We'll say, hey, you no longer have a reference to this variable over here. You must not want it anymore. We can give that memory back to the operating system. It's a useful process. Helps make sure we don't hold on to memory we're not using. Right? So like if I just do a loop and I want to loop a million times and I do something with a number, I don't keep a million numbers in memory. Right? I use the number and then I throw it away. I use the number and I throw it away. I use the number and I throw it away. So I'm not storing all of those at one time. It just makes our programs more efficient. Okay, so lots of practice with classes here. We got to talk about the next project. So we're going to use classes in our project. So our actual project 3 here, because sorry about that. So you probably got an email and we're really confused why we had a project. Let me change this here. So this will be due now. Looking at our schedule going out here. So for the midterm, right? I'm actually out of town that week. So on Monday I will post last year's midterm. Not that you folks would do it, but some folks go and take exams and they post them on websites that they're not supposed to. So they tell us you should rewrite your exam every semester. So I'm fine. I'll give you last semester's or last year's midterm because that's perfectly fine. I need to write a new one anyway. And that way you'll see what the questions look like. So it's going to be 15 quiz questions from the quizzes or styled after the quizzes. I always tell you they're quiz-like questions, and I just use the same test bank. But quiz questions, 15 of them, 1 point each, and then 3 programming questions worth 5 points each. So half the test counts from the quiz questions, half the points come from these 3 programming questions. Right? We'll do like one on loops. Write a loop that does something. Write a function that does something. Do something with strings or lists or dictionaries, or I probably won't even do a classes question at this point because that's more than we want to tackle. We're just now talking about it. We only just had the first lab. So loops, functions, and then strings, lists, or dictionaries for the third one, or maybe some combination of like using a string in a list and that sort of thing. But short style questions. So you'll see what they look like. So I'll post that, excuse me, on Monday. So instead of coming to class, take a chance to look at the midterm and practice it. Try solving it yourself. I'll post the answers later, right? But if I just give you the answers to it, there was like no exercise there. So take the time, do that. Maybe solve the problems, the long answer ones, in the lab time. So there's no meeting for lab. You're welcome to go to the lab if you want to use those computers there, but I won't be there. There's no new lab assignment going on. Practice those long answer questions, the programming questions. And then on 11/2, the midterm will open, and it'll be due by 11/7, the start of class. So just like the chapter quizzes, you can start it, you can open it, you can save your progress, you can come back to it. There's no time limit on it. Right? I don't think that's a good way of assessing if people can do things. Not that you get unlimited time in the industry, but no one's like, sit down in an hour, get this done, and don't stand up. That just seems silly. And I don't have a lot of things memorized. I think you've probably seen that when I have to go Google for really basic things. And that's okay. Right? You're not going to keep it all in your head. You just need to go where you can go look it up. So it's open book, open notes, open internet, not open neighbor. Right? You can't ask someone else to do it for you. You can use your own resources and look things up yourself, do your research. I hate telling people that. It seems like such a cliche phrase nowadays, but like do your own looking up research. That does not mean you can take the question and post it on Chegg and have someone answer it for you and then say, look, I found it online. Obviously, that's bad, right? I don't know why I have to say that because someone thought it was a good idea 3 semesters ago and they failed for it. It's why they thought this was allowed because they found it online. No, you posted it online. Like, I don't understand sometimes. So definitely don't do that. Just thanks for the reminder to hydrate. Answer the questions yourself. You'll actually get 1 free point at the beginning for agreeing to the academic integrity policy, saying, I will take this test myself. I understand it's open book, open notes, but I will not go talk to someone else about it. You get a free point for that, which interestingly, they had some research. I forget which school did it. They had this question at the start and the question at the end. Like, hey, by the way, I assert that all this test I've answered, I've done my own work. People are more likely to lie at the end because they might have already cheated and they're not going to go back and erase their work. They'll be like, oh, it's probably fine. But like if you ask them first to say, please don't cheat, most people don't cheat. It's actually really cool. Like, hey, I understand I'm going to do this myself. I'm not going to cheat. And then like they'll hold themselves to it because they think their word's meaningful. And like, I promise not to cheat. Okay, I won't cheat. And most people are great. So that's always the first question on tests now for me. And you get a free point. Like, tell me you're not going to cheat. Good. Okay, life is good. That means it's not worth cheating. Like, it's a small exam, it's an easy exam, and if you cheat, you fail the entire class. And this class is only offered once a year. You have to wait till next fall to take it again with me because I'm the one who teaches it. And I'm just going to be upset because you cheated on one of my tests. Right? Let's just not do it, please. Okay? Promise it's not hard. I'm sorry?
What time?
So start of class on 11/7. So you've got all Wednesday, Thursday, Friday, Saturday, Sunday, up till Monday when class starts. Yep. Thank you. So we're going to start project 3 today. We've got a couple more minutes to talk about it, and then it won't be due till I want to have that due the 14th. So not the usual Wednesday like we've been doing, but there's a little extra time. So it's not 2 weeks; it's like 2.5 weeks worth of time for project 3 because we have the midterm in the middle. I'm assuming it's not going to be super crazy and take you hours and hours and hours to do because it's designed so that you could take it in an hour 15. Like you come to class, sit down, and take an exam. I just don't do that because I don't believe in it. Okay, so that's the size of this midterm. So it shouldn't be super long. So you should have some time to be working on project 3 as we go here. Okay. Yeah. So like anything else, if you're referencing someone else's work, someone else's idea, cite your source. I'm going to write the questions and Google them, and I probably won't find answers to my questions. So if I give you a question you can Google an answer to, that's my bad. Right? Like they pay me to write questions. One of the things I'm supposed to do. So perfectly fine. And that actually happened once because I didn't Google well enough. Like I like phrased it differently. I was like, oh no, there's no answer out here. And then like they changed how I worded it and there was an answer and I was really sad. But they got the points because they cited their source. That's fine, right? It's okay. Cite your source. So project 3, then we'll start the final project on the 14th, then we'll have all month long to do that final project. This is the most interesting thing we do. We put everything together, have a more interesting at the end solution here to show off. Again, we present those projects. We don't take a final exam. You take your turn to be up in front, show everyone your code, and we'll go from there. All right, awesome. So let's talk about that project then. So project 3, this one here. So let me get a GitHub repo for you real quick. Project 3. All right. Please submit the URL to your repository. Projects points URL, not 11 a.m. So this will be 12:30 p.m. Right? Start a class Monday the 14th. So please don't wait until the last weekend and ask me lots of questions over the weekend. Like I'll try and help you out here, but I have limited time over the weekend to help with you folks. So start it earlier, please. We'll be in better shape. Okay. So we're going to write a class that represents a Powerball lottery ticket. Okay, so Powerball.com, yep, is a lottery that loses people money, lots of money. Right? The states do this because it makes them money. Go figure. Just like any casino game, the house always wins. But if Michigan didn't offer it, people would go out of state and spend their money, and other states would get the money. So we think we're missing out, and so we just let people lose money. Okay, I have opinions about lottery, but that's okay. So how it works is you get 5 white numbers from a bucket of white balls. So these are numbers with no repeats. They come out of the same bucket. 1 to 69. So 5 numbers, 1 to 69, plus a red ball, which is 1 to 26. Because, sure, why not? If you match all 5 plus the red ball. Now, when you match with Powerball, you're matching in combination, not permutation. So because they come out of the same bucket, I don't care if you have the number 1 as your first number, or the number 1 as your last number, or the number 1 as your middle number. If both tickets have a 1, you've matched the 1. Right? Combination, not permutation. So order doesn't matter. Right? If you match all 5 white balls and the red ball, you get the grand prize. Don't worry about these power play things. It's ways to lose even more money, even faster. More nonsense. You get the grand prize. Now, the grand prize changes in real life. In our code here, I don't know how to make it change in real life or change in the code without it being overly complex. So just pick a big number. It's probably around, what was it, around $1 billion or so, 700 million. Go up to $1 billion. I don't care, right? Go for it. It's perfectly fine. And the higher it gets, the more people play, because like people are attracted to large numbers. The odds are still the same. And then if 2 people win, they actually have to split the jackpot. So like just because the where's my odds of winning here? Just because 1 in 292,201,338 tickets will win doesn't mean if you buy all 292 million tickets, you will win and get the entire jackpot. By the way, it's physically impossible to buy that many tickets. But even if you could, you might split that winning with someone else. So, and it's $2 per ticket. So you're spending almost $600 million to win $1 billion, which you're going to lose 40% of to federal income tax and then 4% to Michigan's income tax. And then you don't even get the full amount if you take the cash out prize at once. Usually they give it to you in an annuity, which is a whole other story. So you don't win the lottery. Okay, that's the moral of the story. You don't win, right? You only lose the lottery. So these are the odds of winning, right? So any prize is a 1 in 24.87 chance here, because winning $4 is 1 in 38 here. Why 38.32? Okay, so this is the odds of only winning this and not winning the other ones. So odds get really funny. Go talk to one of your math profs. They're much better at this than I am. We got some really cool stats folks that I'm friends with because they're just amazing. So winning at least something here is 1 in 24.87. Right? And you go on up from there. So this is Powerball. So we're going to write a class that represents Powerball lottery ticket. So we're going to include an init method that generates random numbers for the ticket or uses numbers given. To do something that's or, right, is a default argument. Right? You've seen default arguments? They said, hey, if you want to give me this argument, go for it. If you don't give it to me, here's a default value. Does that ring some bells? Have we seen that? Do we not do that? It's in Zybooks, right? Did anyone read Zybooks? I'm not sure what's happening now. In functions, like, hey, you can say, hey, amount, let's default to 0. If you give me the amount, great. If you don't give me the amount, I'm going to assume it's 0. So now when you call deposit in my bank account, you can just say checking.deposit and give it no arguments here, and it won't crash on you. Wasn't this in Zybook? Okay. Yeah, so some of those were optional, right? And splits and things. So, right, so you can have a default here, or you can have it give you a bunch of values. So, hey, if I want to take a 10, a 12, a 13, a 19, a 27, because those are my lucky numbers, which is nonsense, because numbers aren't lucky. You can go learn statistics. Sure, I can pass a bunch of numbers, or I could just get a random ticket here. The chance of winning is still the same, right? Whether or not you picked the numbers or not here. But we should do both with our init method. Okay, so or uses the numbers given. Okay, then we're going to have it include a method or a function. Sorry, init function. Functions and methods are basically the same thing. I get confused. Some languages prefer to call them one or the other. Get winnings. Then to use get winnings, you need to give it the winning ticket. So you're going to give it another instance of a Powerball ticket that will assume this is the winning numbers. So I can compare my self attributes to the winning tickets dot whatever attributes, right? Like we did with bank account, when we compared my bank account to another bank account. They are the other. I said, hey, other dot get balance compared to my balance. Now, again, I have 5 white numbers and 1 red number, so there's a little bit more that has to happen here. Right? It's not just does my number equal your number, that sort of thing. But we'll compare to another instance of the ticket. Okay, so that's our Powerball lottery ticket class here for get winnings. Okay, so that should return the amount 1. And hard code billion for the jackpot if you want. Okay, so that's the Powerball ticket class. Then what we're going to do is we're going to create a simulator so people can go lose money on the computer and not lose real money, and maybe that'll scratch their itch. And they'd be like, hey, this is fun. Have you ever seen people at a casino playing slot machines? They look terribly bored and really sad. But they sit there just to plug in money in. There was apparently wearing an adult diaper to the casino. It commonly happens because people don't want to walk away from their slot machine. Addiction is really powerful, and we should treat it as a mental health illness. It really is. I don't mean to make fun of people who are addicted to gambling because it's a serious issue. I apologize if it came off as that. But anyway, so get winning. So we will build a simulator here. So we're going to build a Powerball simulator that allows someone to play as much Powerball as they want. So we're going to ask them if they want to pick numbers or buy random tickets. If they want to pick numbers, ensure they pick valid numbers. Then create a ticket. Right? If they want random tickets, ask how many. Right? You want to buy 292 million tickets? Go for it. Have fun. We'll see how fast you lose money. Right? It'll happen. ask how many, and then generate that many random tickets. Then generate a random winning ticket. Right. So once they either pick their numbers or they say I want 1,000 random tickets, generate another ticket, and we'll just call that one the winning ticket because it doesn't matter which one was the winning ticket. Right. Here's a new ticket, random numbers. This one's the winning ticket. Right. Then we'll compare the tickets bought to the winning ticket. Display tickets that won money and the total won, total spent, and the net loss. For them to repeat as often as they want. So to display the tickets that won money, right, you probably want include a function string, right, to override that string. So you can just print the ticket. You don't necessarily need it here, but you probably should. It'll make life easier. Otherwise, you have to say, hey, give me the Powerball ticket first white number. Give me the Powerball ticket second white number. Give me the Powerball ticket third white number, and print those individually. If we just define a string method, we just say, hey, print the ticket. So we're going to print all the tickets that win money, total won, total spent, net loss, right? And at the end, right? The end, right? So, hey, if they bought one ticket and didn't win any money, we don't show them their ticket, right? We should probably display the winning ticket. Display the winning ticket. Compare the tickets, display any of that won money. So if I bought 1,000 tickets, show me of those 1,000 which ones won money, right? With my get winnings, which ones got money back. And then they just keep on going. The total spent, net loss, right? If you don't have a net loss, you did something wrong. You should not be winning money on this. If it shows that you're winning money, your code is wrong. That's it, right? So they can play. All right, I don't, oh, sorry, we're about out of time here. I don't have a rubric set up. We'll build that in a little bit. It'll be worth 20 points. Can we talk about that when we come back? All right, sorry to hold you over. So don't come next week. Right? I'll post the sample midterm. You can practice the sample midterm for lab time. Take the sample midterm Wednesday if you want, or all weekend, right? Just have it done before next Monday. And I will see you folks in November. Have a great Halloween.